AI is evolving fast. Are you ready? Meet AI at FlytBase, your weekly hub to learn, upskill, and stay ahead in AI world. Let's dive into today's session.
If you are someone who really loves to learn about these new models and want to actually try them out, this is something which will be very beneficial for you. And apart from that, we will be going through a lot of other platforms. We will focusing mainly on Hugging Face. I will give you live demos on how I do things around here if I have to test some things out or run new models and everything, because it's still a hard thing to do even after this much AI has been done. And going forward, we can actually talk about how to productionize them or even test it out and create a kind of a working thing out of it. So we can actually run these kind of models which are not mainstream in our applications, because we all know running Claude everywhere is not feasible for like us. So let's just start with running AI models that actually work. So what we do here at FlytBase is we are a physical AI company, so we need to actually process a lot of data which is not text. It's mainly either through images or videos. So the problem statement that uh, we usually go around is like, how much info can we actually take out from these videos or images? So if we all know, like, video processing and video generation is kind of which is like really taking off, but video understanding and image understanding is something still which lags behind. But there are a lot of indie developers that do a lot of stuff around this VL models. They either optimize them or give out new versions for them, or they fine tune them for some particular things. But with this indie developers, what is one of the main thing that happen is we all have their model access through Hugging Face, but we don't know where to run it. So Hugging Face is like really cool. If I can just show you guys. So this is Qwen 3 VL 8V instruct model. So if I can just show you, there is an interface provider for inference. We can actually just type out anything and can test out these models from here through Hugging Face. We can either deploy them wherever you want, AWS, Azure, and wherever you want. But if you want to use them locally or through notebook or just test it out, there are options for big models which are Qwen 3. So Qwen 3 is like quite popular over here. So Qwen 3 VL is kind of an old, it came out like last year or so. So it is still workable and we can actually test it out everywhere. So I have a collab running over here. We can actually test it out with anything. We just need documents or images to pass to it, and it usually takes in and does whatever is done by these kind of models. But as soon as we go into the area which is like indie developers or people who are fine tuning these models or creating something which is uh, kind of unique or kind of niche for their use cases. You can see there is no inference provider over here. To use this model, there is just one local app setup that is accessible, which is Unsloth. So we as company, we wanted to actually try out one of the flagship model that came in with Qwen 3, which was an embedding model. So video understanding, image understanding is kind of a game for us, but being able to retrieve them through embeddings or even make sense out of them through like image text to text kind of embedding, so that whenever a user wants to, let's say, search, show me where accident happens, that embedding can be done like really easily. But show me an accident where which happened during an intersection, or like if you, as soon as you go into more complex, does your embedding work in that way? But if we want to actually collaborate with text or images both together to a vector, will that work? So we wanted to just test it out. I would not go into the premise of whether it worked or not, but let's just see how these things go. So as you see for this embedding model, again, there are deployment options, but for using, there is not even a VLLM thing going on over here. You cannot use VLLM over here. And being an embedding model, you don't even have an inference provider. So again, coming back to the problem that we had, it was mostly what we wanted to was to be easily able to use this kind of things, but Hugging Face still has some bottlenecks over there. But running these setups locally, so we are usually on Mac developers at FlytBase. So running these systems on Mac is still not possible because if you take up the cost of loading the model and then inference, it actually bloats up. And whether the things crash out or does anything, it usually is a big task to actually run this thing and get a working setup. It usually takes a day or two, and it's a lot. Day or two, and this world is a lot. So what happens is there are no libraries or nothing like inference providers. So what we do is that is something that we'll cover today. And first of all, let's go through Hugging Face like we did like before that. But we can actually just jump to our case study, and then we can actually talk about bit about like beyond Hugging Face and what decision framework I usually use to wrap these things up. So let's see again. So Hugging Face for inference provider, it's not just about being able to inference through the dashboard. They have a like a really great library where you can actually just uh, call in a provider, give your API key, your Hugging Face API key, and you can run majority of the models, the big models that are over there, like the Quinn 3 one we saw, but the new models are usually not there. On these APIs are OpenAI compatible. So what happens is usually they don't you don't need to change code. You just need to change the model name and the provider itself with the API key, and everything works as it is. So we as developers just need to define like 3-4 environment variables, and this thing is up and running, and you can change your model as you want. Second is when you productionize it, there are endpoints dedicated so that you do not face any latency issues or even drop off issues like that. But the main crux is spaces. I don't know how many people have used them, but these are very powerful situations, very powerful thing that Hugging Face has. So spaces are like containerized runtime where you can actually just go ahead and deploy these containers out, or sorry, these models out and use them. Usually what happens is there are wrappers wrapping these kind of models so that you can directly interface through chat. But whenever some new model comes in and there is no handler such that there is inference allowed, you usually go through spaces. Why spaces are powerful? Let's go through that thing in a bit with this case study. So Quen 3 VL embedding 8B on Hugging Spaces, we saw like there were a lot less things going on. So what we needed was we needed again text to images and create embeddings out of it. We needed even video sampling from there. And the wall was again, there was no inference provider. There was no standard pipeline again, because this was not a tokenizer issue, because this was not a text to text model. It was more of a model from either image. It is a model of with images and text to a vector, because we were creating embedding out of it, and running locally was not a option for me. Again, the solution was, again, we need Claude for everything here. So Claude in Spaces was the solution. What we did was we again had a GPU in Hugging Face. We wrapped around a handler file around the model and created interfaces through Gradio. So Gradio is kind of a template that they gave you for Spaces. So Hugging Face actually picks up a Gradio, initialize a runtime for Gradio, and whatever you define in Gradio, they can actually just kind of paint it out or kind of create a front end for you, a small front end for testing these kind of models. Next. So the key decisions that I did was, it's something that we can take forward after we have been through Spaces. So we were over here where we were looking at Quinn3VL embedding. So what I did was I have a space running, how I created it. So you just need to go here and create a space. There are like really small number of inputs that are needed, but this gives you a git address. You just need to clone this up and push your code into it, and it just auto generates everything. So again, this is my space, and if I run it, this is, oh, okay, this is what I see. So this runtime is actually just built on Gradio. I will show you the source code. Source code is not something that we need to keep to ourselves. So this is like my app. I just need to put out some kind of text for embedding. I just need to select an image. So I have an image of my buddy from Claude, and I just submit it out. So there is nothing impressive going on, but these kind of embeddings are gated, and this will actually just push out a new embedding for me. And if I just show you the panel which is on the bottom hand, you can have a API thing going on. You can actually just call these APIs and can inference with this embedding model again. So it's this easy even for indie developers model and models which are not on like inference things and going on. And again, so running this thing is made really easy with HuggingFace spaces. Again, like the settings that I use for my space was I'm actually running a decent CPU over here, GPU over here, NVIDIA One XL40S. I needed this thing because I needed fast answers. I needed like embeddings which were done really quickly because I was creating this thing for a hackathon. And again, so how did I get here? I tried the inference thing. I tried to find like VLLM things going on. I tried on other like renting out a GPU in other spaces that we will talk about after this is done. But everything got solved when I actually created a space out of it. And what I needed to do was just this thing. Let me just show you my code. Okay. I hope this is visible. Aryan, is this visible?
Yes, yes, it's visible.
Okay, fine. So spaces are like really easy to use. Initially, it took a while to actually get things up and running. So this app.py is a Gradio initializer. It just tells that you need a text box, you need an image, and you need a video. And the handler file is what does the trick. It actually just initialize the model, like take the model in and does the process text, image, and video thing going on. So these are just two things I needed to do. Setting up this thing was actually easy. You just needed a README file with all the SDK version, and app file for your input, and this is from where your space actually pulls up what environment you need, and they give you a proper setup, and you can actually just run it out. So just by creating these like 3-4 inputs, I was able to get this thing running and actually test out my code with this API. So this is not the final thing that I showed, but this is one of the main part which was creating the embedding for my hackathon project. Again, so these hackathons are not just one hackathon, but it's like a building block for something that we are thinking about actually productionizing. So it was one of the major issues running these kind of systems that we saw. So like coming back to the PPT that we had, the key decisions that I took was it's actually a little bit code based. So precision auto detection for float 16 if GPU was available, or float 32 if CPU was available. Image padding, video sampling by frames because there was no video input as such available. Using Python headless so that GPU does not get involved, and separation of concern so that if I want to, let's say, expose these things through APIs after I'm done testing in spaces, I just need to change that app.py file from a Gradio initializer to a fast API or something like that. So this was really easy to do with Claude. But if we talk about like things which are more generic in sense, when we want to run models which are um, uh, like popular, there are a lot more options that we can do. So first of all is like the environment creation and things you can use to actually run this thing out. So VLLM is one of the best libraries to run it through. You need a GPU and CPUs for it, so they do not actually provide it. It's a library that actually does it for you. Again, SGLang is one of the things that you do. So these are majorly for productionizing things. You need to if you need to deploy these kind of model, these are the libraries you go for. Apart from that, API gateway. So I don't know how many of us have again visited OpenRouter. OpenRouter was initially just for testing everything out initially, but right now they have done a lot more things. So they have more than 300 plus model, 668 models right now. And if you want to be an indie developer, or if you want to actually test out some of the small models that are not provided by, let's say, your big companies, this is the place you want to go, because having that API interface is way easy to use, and doing everything here is way less overhead. There is no overhead to it. So coming back to our slides, uh, OpenRouter is again has its own benefits. But these provided tools are something which actually gives you an edge when you actually need to productionize this after testing. So replicate together AI, run pod, vast AI, and unslot. These have a different use cases. Again, replicate and together UI gives you an inference kind of a platform by default. You do not even need to actually set up the environment over there. They have everything set up. You just need to choose a select or get your model over there. Run pod and vast AI are different. They are GPU providers. So these are basically renting out GPUs and CPUs from cloud and running your things. So this is where VLLM comes in. That thing containerize everything inside of it, and you can actually use it for interfacing and get everything done like really quickly. So we usually use VAST. Setting up takes less than 15 minutes now. Loading the model and actually running it out actually takes 5 to 10 minutes. So it's like 50-50 time. So writing code and running is takes like 30 minutes to actually get something out. And Unslot is something which I have been trying to use, but I haven't been able to use for quite a while now. It's a space for fine tuning. Rehan, I saw your question, but even I am not there kind of. I haven't been able to use it for any of my work thing. But that is like a really good thing that they are doing, fine tuning and getting your stuff. They have the whole environment set up where you do not even need to take your data in. They have a lot of data sets available, so you can actually fine tune it like really quickly. There are a lot of promises done, but I don't know how true they are. But the guys who are doing it, we have met them in US once, and they like seem like really intelligent. So I don't know, but I need to use that. Again, coming to path that you should take for these kind of models, when you want to actually do a quick test, popular model, the interfaces through HF is the thing to go, or OpenRouter. OpenRouter is a bit costly. HF actually provides you with a lot of free tier things, and their like limits are also like daily based, so you do not actually run them out like really quickly. Again, if this is a niche model and you want to do quick testing and want to get it running, the HF spaces are the place to go. I haven't seen any other place doing this thing this good apart from Hugging Face. Other platform do tell you that they provide all models, but I don't think so. They do. Cheapest GPUs again, Vast AI RunPod is a good place to start with when you don't know stuff. But if you are well versed with deploying these kind of things and you know what you're doing with these models, Vast AI is your place to go. There is no separation of CPU and GPUs. You can get everything in one place, and there is just one cost to it. So it's really manageable and runnable. interfaces also through CLI. You got tunneling and everything. So Astia is a place for you renting GPUs. Now, if you want to productionize it, replicate and together are okay, but HF endpoints, Hugging Face endpoints are your place to be. They are like they even have auto scaling in play setup. So again, production interfaces, again VLLM. I am like really a VLLM fan, so I think so that is a place to be. It's easy to run. I don't know the internals of it. It's just like I just run some commands and it works. I also don't know what they do, but whatever they're doing is like really good. Again, if you want to test multiple models through one API, or if you want to have a failover, or if you really want to do, let's say, if you want to have a kind of a multi-agent setup where you just want one API key to be exposed through it, Open Router is your place to go. Like diverging small tasks to some really small LLMs and keeping the big tasks for bigger LLMs so the cost can be optimized. That is where Open Router like really shines. Again, if you want to customize your model, and Sloth is your place to be, but I am like a big fan for them, but I haven't been able to use them like fully. If your model is too big, quantize. I This is the statement that I won't go too deep into because I haven't been like well versed in it. But this is like the overall picture with your models and decision framework. And Okay, so this was just the wrap up slide that we have, the gap between interesting model and working interfaces where you are now. So the build up is again like the models that we currently have are like really capable, but the cost adds up. So for us being, let's say, if I want to run like OpenClaw, what do I do? Should I provide a Claude API key to it or OpenAI API key to it? But there are a lot of small models that also work like really good. How to use them, how to actually get to these interfaces where a lot of people are not able to get. So this is like the whole picture and how you can get there.